let's dive into the exciting part. We hold a deep admiration for Mark Richards, and it's always a privilege to have him here on the stage. Mark is a highly experienced and hands-on software architect, deeply engaged in the design and implementation of microservices architecture, service-oriented architectures, and distributed systems. Mark has written numerous software architecture books, and he has a very great resource for developers who want to become software architects. His personal website, I guess Mark will tell you more about it. And it is an absolute pleasure for us to start our second day with a presentation by Mark Richards. Mark, thank you for being here with us.
All right. Thanks. All right. Hola a todos. Welcome to day 2 of the Global Software Architecture Summit. My name is Mark Richards, and I'm going to talk about effective microservices and the lessons learned over the past 12 years. I have to say first, though, I really love the theme of this conference, kind of leveraging some of these modern practices in software architecture to be more effective, to be more efficient, and most importantly, to enjoy what we do. So, are we all ready to have some fun? Fantastic. Before we start, I wanted to give a shout out to a thank you for all of the sponsors for making this conference happen. To be able to really bring all of us together, to be able to talk about software architecture, exchange ideas, very exciting. Something else that's very exciting, nuestro libro está en español. Our book last week was translated to Spanish. So I believe this is about the 7th or 8th translation of our Architecture, the Hard Parts book. So this is kind of exciting. I wonder if it was translated by AI or a human. Well, I have yet to read it, and we'll find out. But we're here this morning to talk about some of those lessons learned in microservices. What I'm going to do is show you 5 different topics. And within those topics, we'll talk about the various lessons learned in this rather difficult architecture style. And as a matter of fact, that first lesson is about microservices and the bounded context. So yesterday, we actually referred to the bounded context quite a bit. The bounded context really is that boundary in which the domain model and that ubiquitous language lies. It's part of domain-driven design, and there's all sorts of fantastic resources, including Vlad's book, to understand domain-driven design and the bounded context. So we read all these books, we embrace domain-driven design, and we create all of our domains, subdomains, in our bounded contexts. We get very excited about this, give ourselves a high five, and then we go to implement it in microservices. All too often, what happens is we forget all about all of that modeling effort that we did to create these subdomains and bounded contexts, and we get wrapped up in the weeds of implementing microservices. What's the connection between the bounded context that we do in domain-driven design and microservices? Let's find out. One of the core principles of microservices is that each service must own its own data. It's a core principle we all accept and understand. Has anybody ever asked why this is necessary? Why can't we all just share the same database and get along? Sharing is caring. It's a lot simpler as well. Let's talk about why we can't do this. Because with microservices, especially in orchestrator kind of environments like Kubernetes, we have this ability to auto-scale. All we do is set a configuration parameter. That's it. So we get to do all this scaling, but if we're sharing the same database with dozens, hundreds, maybe even thousands of services, we find the database doesn't scale, which means our entire application becomes a dumpster fire. What if we wanted to make a little change to a service that also required us to change that shared database? Well, certainly I have to find all the services, all of them here, and I have to change those as well. And I have to deploy all of this in coordination. Sounds hard? That's only half the story, because it's the services we didn't know about that were using that structure that causes yet another dumpster fire. So now we understand, okay, I get it. We can't share a database. There's too many services. So what we have is each service owns its own data. But what if I need your data over there or your data over there? Well, I go and query your database. And of course, I go to apply a change to my database, and I have to change you and you. But I also forget about the services that were accessing my database that I didn't know about. This is what Vlad was describing as the intrusive kind of coupling. As a matter of fact, this had all 4 levels of the coupling Vlad was talking about. Yikes. So we come to, basically, the point where yet another dumpster fire. So, comes to our first lessons learned. Microservices will never work, so don't do it. Gracias. Oh. What are all of you still doing here? No. It will work. Of course it will. But how? Now we come back to the bounded context. All of that work we did, modeling, creating all those domains and subdomains in bounded context, we realize it through microservices through something called a physical bounded context, which describes each service owning its own data. And when I say owning its own data, that service is the only one who can access that data. But I need your data, and I need your data, and your data too. Which means now I have to ask for it. Now that action is manifested through the bounded context consumer-supplier collaboration patterns, the ACL, or maybe it's a partner. This is how to make microservices work. So now, when I apply a change, I'm the only one impacted. That's my data. That's my internal representation. I have changed the strongest coupling level, intrusive coupling, down to the weakest level, contract coupling. So now, all the services are fine. So we come to our very first lesson learned. Yes, microservices will work. We've been doing it for 12 years and very unhappy with doing it. But our first lesson is this: to pay attention to that physical bounded context. Everyone, this is the only way microservices will work. That's the connection between all that work we do in domain-driven design and our implementation of that design and of that model. However, a question. How realistic is this? You got it. Not very. Which brings us to our second topic, which is data sharing for fun and profit. Let's go back to where we just were in our first lesson. Building that physical bounded context, which hopefully I convinced you is the only way to get microservices to work, creates something called the database per service pattern. How do we create this? Well, we take all of our database tables and we assign ownership to services. Now, the owner of a table is the one who writes to it. That's the owner. And now we form nice, tight, formed, physical, bounded contexts. You're right. How feasible and how realistic is that? Because what else is in this database? Foreign key constraints, views, triggers, stored procedures. And if we try to form bounded contexts, which I own my own service, you do know what we have to do. We have to actually cut every one of those lines in order to form a bounded context. Do you know that there is a shortage of data architects and DBAs in our industry? No, really. There's a shortage now, thanks to microservices. Why? Can you imagine walking up to your DBA or your data architect, staring them straight in the eye, looking at them and saying, "We're moving to microservices. We have to remove every foreign key and every trigger and every view in this database." What do you suppose happens? Oh, I've seen it. Their face turns beet red. Their head starts shaking like this. And then it just, boop, it pops right off their shoulders. Boom, heads popping off, DBAs. It's quite messy, but quite fascinating to watch, actually. Of course we can't remove every foreign key, every trigger, every view. These are used for data integrity. So what do? Once again, we have a dumpster fire because we can't do this. So, the solution is another pattern. It's called the domain data pattern, where we still have to cut some of these lines. But you see, this section right over here, all the data that's coupled together, the same as this section right here, and the same as this section. So I can preserve those artifacts within that domain. And again, I come back to all that modeling we did in domain-driven design. So visualize, if you will, each major section of this room, and everybody's kind of randomly shaking a hand with somebody else. That can still happen. But Sonia can't shake Christian's hand because there's an aisle there. That's the idea of domain data. So now what we end up forming is a broader physical bounded context. Oh, we still have it. But now there's more services talking to this section, or more services talking up there. So, why do this? 3 reasons. When we have highly semantically coupled data, with all those artifacts, all those relationships, all those foreign keys, maybe it's logical connections. All this data is related to one domain. That's the first use case. If we have multiple owners of particular data, well, who should own it? Me. No, Jackie. No, me. No, Jackie. No, me. Well, how about both of us own it? But you kind of have to establish an owner. Both of us would own that data. Suppose you have an extremely complex query that requires a lot of joins, group bys, havings, everything you can imagine to create this data. Can you imagine calling 10 microservices and trying to do all of that in your code? No. These are 3 reasons to use domain-based data. Of course, as with our first law of architecture states in our book, everything in software architecture has a trade-off. Oh, there's negatives. Change control becomes harder. Because now I have multiple services within my physical bounded context to change. And also, this could have a negative impact on scalability and availability. I'm impacting more services than just one. So we come to our second lesson learned. And that is this. It's okay. It is okay and sometimes necessary to share data in microservices. This was a hard lesson learned because of the arguments. You can't share data. It's one of the core principles of microservices. Good luck trying to get it to work. So now that we see our second lesson, a question. Well, if that works, then why have separate services in the first place? And if we're all sharing data, shouldn't we combine those services? This leads us to our third topic. And that is service granularity. Now, isn't it interesting? Yesterday, we heard from both Nick and Vlad that service size was a least important metric. That it doesn't become that important. While I agree in some cases, in most cases, I don't. Service size is important. Back in 2015, I coined the grains of sand anti-pattern for microservices. Now, the grains of sand anti-pattern is where we start to do microservices, and we make those services as small as possible. Every function as small as possible, just like the grains of sand on the beaches here in Barcelona. It's an anti-pattern, and it leads to really bad things. So then, if size actually is important, and I'm going to show you why, what size should a service really be? Don't get me started. Depends. Of course it depends. I was laughing at Neil yesterday in the Q&A because I'm thinking, how do you answer questions in an architecture conference Q&A? By always just saying, it depends, next question. And suddenly it doesn't become very exciting, does it? Because we already know the answer to the question. I actually have an architecture shirt. As you can tell, I love the color black. And I have a black t-shirt, and I call it my architecture shirt, because on that black t-shirt are two words. It depends. Love it. I wear that all the time. I forgot to bring it here. Shame on me. Funny story. I love that shirt, but I only have one. So sometimes with sizes when you order online, sometimes I wear a large, but depending on the manufacturer, sometimes I wear an extra large. I wasn't sure which one, so I ordered two shirts. It depends. One that was large, one that was extra large. Turns out with this particular manufacturer, extra large fit me perfect. So I'm at my computer, my spouse is next to me, and I'm ordering 6 It Depends shirts. She looks at me and she says, "What are you doing?" I said, "I'm ordering 6 shirts." She went, "Oh, men." She said, "You do know that those are all the same." "Yeah." "So when you go and speak or do a class or do a training or go to work, everybody's going to think you're wearing the same clothes." So I do have 6 It Depends shirts, but they're all different styles. Sometimes it's all caps, cursive. That way everybody knows I am, in fact, changing my clothes every day. Well, it turns out that size is important. But the word micro does not refer to the number of lines of code or the number of class files at all. What it refers to is what the service does. 300 class files in a micro service? You've got to be kidding me. You know what that service does? It sends emails to our customers. Single purpose. It does one thing really well. However, it's only 2 class files to send an email, but we have 298 different emails we send. Each email is manifested through a class file using the strategy pattern and the template pattern. So a particular type of letter or email we have to send, I simply instantiate that class, fill in the data, send. 300 classes. Single purpose. So, let's go back to our second lesson. And let's look at that first bounded context. Well, if we're sharing the data, then why separate the services? Turns out there's two forces at play here. The first are granularity disintegrators. Those drivers that say, oh yeah, keep them apart, or break it apart even further. And that first one happens to be the functionality. You see, in our case here, every one of these services does something different. But they all share the data. That's okay. Maybe it's code volatility, the rate of change within those services. This is a software architecture metric we can measure. It's a rather simple git command. And we find that this service changes all the time. But these services rarely change. By breaking apart and keeping these services different, I now have reduced my testing scope. I have reduced my deployment risk. And I have increased agility, the ability to respond quickly to change. It's a good reason. Good reason. Maybe it's about scalability and throughput. You see, this first service right here has throughput of 220,000 requests a minute. The second one, 500 requests a minute. And the third, only 10. Scale differently. Each function scales and has different throughput. Another good reason to say, yeah, these should all three be separate services. Maybe it has to do with fault tolerance. You see, this service fails all the time. Comes crashing down. These two are fairly stable. So now when that failure occurs in that function, all the others are still up and running. There we go. Good reasons to keep them separate. But we have to balance those with granularity integrators. Those drivers that say, no, put them back together. And it's amazing. The first driver happens to be the data dependencies. You're sharing data. Now, if we have no reason to keep these separate, none of those disintegration drivers apply, then put them back together. Because now I have a tighter, bounded context, better change control. So now, maybe it's about transactions. You know, when we have separate, even though we're sharing data, if I have separate services and I make a request, well, that first update happens from the first service. Whoops, commit. The second update happens during the request, commit. The third update happens, commit. We do not have a database or ACID transaction. We have a distributed transaction now. So, putting them together, we do that same request, and all these updates occur now within the scope of an ACID transaction. Now I can do my commits and rollbacks. So transactions are important or even necessary for data consistency and data integrity. Put those services back together. The third happens to be workflow and choreography. You see, now that they're separated, I go to make a request, and sure enough, now I've got functional coupling, which I call semantic coupling. And now we have a problem because this service right here is non-responsive. It's down. What's my only option? Error. Try again. This can get very annoying to a customer. And The other problem is, if I make that single request that requires all these services, how long is that going to take? The answer? Too long. So now we see our other integrator. It's about latency. And by bringing those services together and combining them, not only do I have a tighter bounded context, but now I make that request, and it's a lot faster. Much better fault tolerance. Interesting, isn't it? So, we come to our fourth lesson. And that lesson learned about this is granularity is not a guessing game. Actually, this is our third lesson. What it requires us to do is analyze those disintegration drivers, keep them apart, and the integration drivers, keep them together. And analyze the trade-offs of those. That's the game. It's not a guessing game. Microservices size does matter. So we come to another question. Why is this so hard? Why are all of us in this room, including me, struggling with microservices? This is hard stuff. The reason why? Something called isomorphism. Now, I will explain this term, but let's look at a scenario first. Here's the business sponsor. Well, we expect constant change in this system, okay? And we need to get those changes out as quickly as possible. Okay, so we know we have agility. But we expect significant customer growth in the next 6 months, particularly as we aggressively acquire new companies. That's all about extensibility. That's all about scalability. That's our problem. Is that a good problem statement? No, it's not. But I didn't see your talk before this, so had I done that, I would have revised my slides. Okay, so what does the architect do? They go to our book, The Fundamentals of Software Architecture, where we rated all of the architecture styles over the course of 7 years developing this into star ratings. 1 star means, yeah, that characteristic is not so good. 5 stars, really awesome. Yeah. So, what's our problem? Our problem requires agility, deployability, testability, extensibility, evolvability, scalability. That's what's important to us. We do what's called quantitative analysis. We compare qualitative analysis. We compare the quality of one thing to the quality of another. And what do we find? Look where all the 5 stars sit. What's the clear choice here, everyone? Microservices. Yeah. So, we start implementing microservices. It's a clear choice. I think everybody agrees we did the right thing. And we find all the services start talking to one another. It looks like a big ball of distributed mud. This is what we call an epic failure. But why? I did everything I was supposed to. I extracted those architecture characteristics, those ilities from the business requirements. Check. I went to the star ratings chart. I did qualitative analysis. This is the clear winner, yet we have an epic failure. Why is this so hard? because of isomorphism. Isomorphism is a funny word. It comes from Latin, isos, meaning equal, and morph, meaning form and shape. Isomorphism is asking, does the shape of one thing match the shape of another thing? And all too often, this is like putting a square peg in a round hole. We can use this concept in architecture and extrapolate this to architecture to domain isomorphism. Does the shape of the architecture match the shape of the problem? Turns out, every architecture style has a shape. Turns out, every problem you are trying to solve has a shape. For microservices, what we're talking about this morning, the shape of that architecture is single-purpose services deployed as separate units of software, each owning its own data, that has high levels of scalability, fault tolerance, agility, and extensibility. That's the shape of microservices. It has a very unique shape. But what about the shape of a problem? Can you describe your environment, your problem to me? Oh, we have a 200 terabyte monolithic database. We have very tight time and budget constraints. Our teams are organized by groups of UI developers, groups of back-end developers. Here's our database people, and over here is all of our testers. Yes, Conway's Law in action. Oh, but also we have highly coupled functionality. Yeah, it's all kind of combined together. What I just described to you was a shape of our problem. And I'm going to put that in a triangle. How close does the shape of microservices match the shape of the problem I just described to you? It doesn't. That's why we struggle. So this asks the question, well then what shapes do match microservices? Oh, time to market. We have to get our changes out to our customers as fast as possible. Maybe I have high elasticity, scalability needs, fault tolerance, cloud deployments. This is a great shape. These shapes match well. My problem domain consists of a lot of discrete individual datum and also discrete functions in my system. That's the shape that matches. So the lesson learned here is really this. Microservices has a specific shape. Isomorphism does matter, and it's not always a fit for the shape of your problem. That, everyone, is why we are struggling with microservices. So this leads to our last question. Well, how many domain shapes are there for microservices? Not many. I've been doing microservices for about 12 years now. I was a very early adopter. And back about 10 years ago, a new phrase came out. You know what that phrase was? We're not Netflix. It was everywhere. So many companies were saying this. You see, Netflix did, in fact, have a good isomorphic shape to microservices. We got excited about this and tried to take that shape and put it into our banking application, our insurance application, our logistics application, our packing application, our warehousing application, our financial application, our trading applications. And guess what? It doesn't fit. We're not Netflix, which leads to our very last lesson. That is hybrids. So if we look at another domain, very similar, that we need a new system that can support an increasing number of customers. Expect a lot of change. Customer satisfaction is number one. We do the same exercise. We go to the star chart, and we find that microservices is, in fact, a great fit because it satisfies all of those things with 5 stars. There's something I didn't tell you before. With all those 5 stars, there's a lot of 1 stars too. Interesting. So, we choose microservices. It's a good domain to, it's a good isomorphic fit. We have a good shape to that. So we've got customer-facing functionality. We have some back-end administrative functionality. And we find this, though. Here's all of our superpowers of microservices. Customer-facing needs all of those, don't they? Back-end admin, single-user stuff does not. It's a great isomorphic fit. The shapes equal each other. But what about the negatives? Performance, cost, complexity. Well, yeah, we do trade-off analysis, and we're willing to trade those off to have the superpowers. But over here, it's all the pain and no gain. There is no benefit whatsoever. And we have our next epic failure. I should probably bring that slide up that said, microservices will never work, don't do it. I should have kept bringing that up. It seems like that, doesn't it? The gloom and doom session from Mark Richards, yes. How do we fix this? Well, let's close this session by showing you the last lesson. When you do microservices, think about that grains of sand anti-pattern. We first move greenfield or migration to something called service-based architecture. This is where we can share monolithic data. We still have services, but they are coarse-grained domain services. Now we can ask the question, who needs these superpowers? Well, certainly this domain service does over here, but this domain service does not. So we keep this domain service, a large, coarse-grained service that shares data, and over here we move to microservices, creating a hybrid architecture. Everyone, hybrids are the new king. They are. This was our last lesson learned. Are you ready? Not every portion of a system has to be microservices. If you start out just with microservices, you don't realize what things shouldn't be. So, let's review our lessons really quick here. So we had 5. The first lesson, pay attention to that physical bounded context, everyone. It's the only way it will work. Lesson 2 that we learned, it's okay to share data in microservices. I showed you 3 reasons why we may have to share data. Lesson 3, granularity is not a guessing game. The size of microservices does matter. That size is what it does. Lesson 4 that we learned, microservices has a specific shape. check the shape of your domain. It's there. Does that match microservices? Maybe it's not the right choice. In that final lesson we saw, not every portion of a system has to be microservices. I'm going to close this session with one more lesson learned. And it's this: be effective, be efficient, and enjoy what you do. This should be fun stuff. You can leverage these practices and other practices you are learning at this conference to make our job just a little bit more fun. Thank you so much. Thank you.
Thank you, Mark. We love you. Your presentations are always so insightful and valuable. Thank you so much.
Thank you.
We already have a lot of questions, so let's start. You hear me well from here? Yes?
Yes.
Okay, perfect. So the first question, instead of data share, what about creating data replicas per microservice for reading and use API for writing?
Data replicas.
Yes.
Correct? Yes. So a data replica, in most cases, is a copy of my structure someplace else. So I have a structure over here. And I replicate it way up there in the corner. They don't have to call me now. You're absolutely right. I've got a replica of my data. How do I keep that replica in sync? Because we're highly decoupled. Well, so I'm going to need a change data capture or some sort of replication scheme. What if we drop a table? Who am I impacting? Every one of those people up there in that section. This is the problem when we ask, well, can we create views in microservices? Can I do replicas? Think about that first lesson, the bounded context. If I make a change, that bounded context, that data is internal to me. It's inside my body. When I change that, who am I impacting? That's the problem when we start talking about replicas and replicated data. Yes, by the way, it is an option. What I'm describing to you are the trade-offs of doing that. Low volatility, very stable data structures. Yeah, it's probably a viable option. In most cases, we're now coupling these two bounded contexts and all those services together. So yeah, that's the trade-off of using data replicas and views and stuff like that.
Thank you, Mark. Next question, how to minimize the horizontal crosstalk between microservices?
Yes. Very insightful question based on the lessons we just learned. Ooh. So, let's go back to our example. Let's say you need data from the gentleman in green with the cool hat way in the corner there. There you go. And you need that for processing. One of the ways of avoiding a synchronous call to get that data that I typically use is in-memory replicated caching. Things like Hazelcast, Ignite, Gemfire, Coherence, InfiniSpan. So this gentleman would have an in-memory data grid with all the data. And so do you. And so do you. And so do you. And all that is kept in sync, near real time, through these tools. You've already got the data in memory. Don't need it. Don't need to make the call. As a matter of fact, if you got up and left right now, we'd all be okay, because we still have your data. So that is one of the techniques to use. Service granularity is the next one. If you constantly need data from Sonia, and you can't, it's too much data, then just join up. It's another way of dealing with this communication problem. So anyways, those are two out of probably another session I could actually talk about. That was a great question.
Thank you, Mark. Feedback. Good talk. What's your definition of service? Is it possible that it's more than one deployable artifact?
Could you repeat that one? I don't see it on here.
Yeah, good talk. What is your definition of service? Is it possible that it's more than one deployable artifact?
Not in the definition that I'm using. So a service is a single deployable unit of software. Whether it be a single-purpose, fine-grained function, or whether it be our entire order fulfillment processing in one service. So it would be defined as a single deployment unit for purposes of how I'm defining it. Yeah. Yep.
Thank you. Having two servers right on the same table, DB, has a lot of negative trade-offs. Could you share a scenario or use case that this works well?
Having the first part, could you repeat the first part?
Having two servers right on the same table, DB, has a lot of negative trade-offs. Could you share a scenario or use case that this works well?
So we're talking about multiple services writing to the same data. Yeah. I'm going to split this into two because we have the necessity sometimes to write to the same data, but not necessarily the same datum, the same field. A good example might be a customer table where Sonia happens to be updating the profile. Vlad happens to be updating some other portion of that customer functionality. So those are pretty typical scenarios. The last one I could think of is something like we're updating inventory of something. We're all updating copies of my book that has a particular inventory. But these are things we would do in a monolith or in a distributed architecture. This problem exists in any architecture style, not just simply microservices. So.
Okay, what is your favorite dumpster fire story?
Oh, how much time do we have? Oh, boy. A favorite dumpster fire. Specific to microservices? Oh, boy. Way too many. I think one of my favorites, which kind of is the most common, is things start out nice. We create a new application, and everybody's individual. And as we start maintaining and adding new functionality, we start all shaking hands again. And something that starts out pristine, perfect, turns into a horrible, horrible mess that is extremely hard to refactor. I think that is probably, that's interesting. When we talk about our favorite dumpster fire, that's probably the worst one I experienced, was things starting out nice and ending up just not working. Because we're way into production. And that's hard to refactor. So that would probably be my favorite microservices dumpster fire, yes.
Thank you. And last question. Is serverless favoring any architecture anti-pattern?
So is serverless
Is serverless favoring any architecture anti-pattern?
I didn't catch the last word.
Anti-pattern.
Oh, no, I don't think it could be. It depends. There you go. I tried to avoid those two words in my session. So serverless, to me, is not a separate architecture style. It's a deployment strategy of microservices. The serverless function is a separately deployed single-purpose function that does one thing really well. Like microservices, that deployment strategy, most of us got caught up in that jump on the bandwagon hype wave. And we failed to realize isomorphism. Does the shape of my problem really work for small lambdas that have a startup time, that struggle to connect to data sources? Not really. And so I would say that it's more not an anti-pattern, but again, it's part of that lesson learned about isomorphism. And does the shape of my problem lend itself towards lambda functions?
Thank you, Mark.
Okay, thank you so much.